Hello everyone, welcome to this session number 8 in your module Big Data and Business Analytics. Today we are going to continue explaining some essential maths and statistics which are connected with data science, and basically these are the learning objectives for that session. You will gain some knowledge in statistical areas connected with data analysis. Particularly, we are going to focus on the utility of inferential statistics in hypothesis testing. Through this session, you will initiate your learning on inferential statistics. First of all, I would like to recap the importance of statistics in data science. Basically, we can use the statistics to summarize the raw data by using descriptive statistics, the univariate analysis, that what the statistics methods that we were covering in our last session. Also, we can use statistics for group identification through factor analysis, principal component analysis, cluster analysis, or logistic regression. These statistical tools will be covered in future sessions, but also we can use statistics to find differences within groups in our data by using bivariate statistics, and to find relations between data by using correlations and predict outcomes. By using inferential statistics, we can cover in some way these three last aspects. Study differences and similarities between groups, to find relations between variables, and to predict some outcomes by the use of regression analysis. In our last session, I showed this figure that helped in understanding the differences between descriptive statistics and inferential statistics. And as you can see, we can use the inferential statistics to make inference. That means to analyze what happens in a whole population by analyzing a representative sample of that population. In addition, we can use inferential statistics for hypothesis testing, as we will see, to determine relationships and to make predictions. Commonly, the use of inferential statistics is connected with large data set. So that's the reason because inferential statistics is going to be connected with big data. As we said in our last session, the process are usually more complex than in descriptive statistics, and the error involved could be usually more. Within inferential statistics, we can distinguish between parameter estimates that basically seeks an approximate calculation about a feature of a population, and hypothesis testing that seeks to validate a supposition based on certain evidence, but that is limited. But we are going to infer this evidence by using a sample from the whole population. According with the quantitative analysis process that we explained at the beginning, after cleaning the data, describe the data, and validate the measurement, we can test hypotheses. Hypothesis testing is commonly used in research in drawing inferences about a population based on a statistical analysis of data drawn from a sample of that population. So, as we were explaining last week, we will use a sample to make statistical calculations and to test an hypothesis for the whole population. Depending on the type of variable that we have and the number of variables that we are considering, we will use different methods to test hypotheses. The first method that we are going to cover today is about how to analyze group differences. In case that we have a binary variable, like for example gender, and a dependent variable. In that case, we will be using the t-test. In that case, as we have a binary variable, we have two groups with two means. If we want to check if there is a significant difference between these two groups, we will use the null hypothesis significance testing. So we consider a null hypothesis. This null hypothesis is that there is no difference between these two groups. And the alternative hypothesis, H1, is that there is a significant difference between the groups. So to know which one of these two hypotheses is correct, we need to collect the data and present the evidence to reject or accept the null hypothesis. Our de facto position is that the null hypothesis is true, is that there is no difference between our two groups. Basically, the null hypothesis says that there is no difference between the means, while the alternative hypothesis says that there is significant difference between the means. So we will use the significance test to see if we can reject the null hypothesis in favor of the alternative hypothesis. So when the distance between the two means for the two different groups is small, the value of t will be small, while when the distance between the two means is large, the value of t will be bigger. Also, we need to consider the speed of the variables. This is the variance of the data in each group. You can see here how the speed, the variance of the data can make a huge difference to consider if there is a significant difference between the two groups when considering a variable. Here you can see the equation that we use to calculate t. Basically, we are taking into consideration the means for each group, the variance for each group, and the sample size. And keep in mind the main idea. T increases as the distance between the means increases. Then we have the p-value. The p-value is simply the probability of the null hypothesis being true. As you must probably know, the probability values are always between 0 and 1. If p is 1, it means that the probability of occurrence is 100%. When p is 0, it means that the probability of occurrence is 0%. We said that our starting position is to assume that the null hypothesis is true. Therefore, we are assuming that the value of p is 1. We are 100% sure that the null hypothesis is true. Then we collect and present the data, and this will likely show a difference between your two means because they are rarely perfectly identical. So the likelihood of the null hypothesis being true will drop from 1 to something smaller, like for example 0.9 or 0.8, which represent that there is still a 90% or 80% sure that the null hypothesis is true. And how p and t relate each other in a t-test. Basically, as the distance between the two group means increases, the value of t increases. We already said that. And therefore, the probability of p, the null hypothesis, to be true will decrease. Here you can understand graphically better the relation between t and p. You can see that here the means of the two groups are quite close, so the value of t is small and the value of p is close to 1. Like for example, t being 1 and p being 0.8. And here you can see that the means of the two groups are clearly different. Now t has a value of 4.2, while p is 0.0001. It's now very small value, closer than 0. So it means that the probability of a null hypothesis to be true is very, very small. So we can reject the null hypothesis when the likelihood, the probability of the null hypothesis being true is so low. The level we make this rejection, it's what we call alpha level, and this usually takes the value of 0.05. So when the likelihood of the null hypothesis being true is less than 0.05 or the 5%, we reject the null hypothesis in favor of the alternative hypothesis. While when the likelihood of the null hypothesis being true is greater than 0.05, we fail to reject the null hypothesis. Here you can see graphically the alpha level. So in that case, P is smaller than the alpha level, so we will reject the null hypothesis and we will accept the alternative hypothesis. So it means that measuring this variable, these two groups, has a significant difference. Here you can see an example of two groups, two categories when measuring a continuous data. In that case is the average weight loss by following two different diets, diet 1 and diet 2. So you can see that the individuals following diet 1 lost less weight than the group of individuals that followed the diet 2. The larger the difference, the less likely this is a random chance. So in that case, statistically, we will show that there is a significant difference between these two groups when we are measuring a continuous variable, which is the weight loss. In the case that we are comparing a categorical variable, it means that we are going to compare more than two groups when measuring a dependent variable. We will use the ANOVA method. The rationale behind ANOVA is similar to the t-test, but in that case we are comparing three or more means to see if they are the same or significantly different. In that case, the null hypothesis says that the means of each group are all the same. And to disprove the null hypothesis and accept the alternative one, we need to find that at least two means are statistically significantly different. So for this test, you usually need a grouping variable with three or more categories and a continuously measured variable. So following the same example than before, now instead of two diets, we can consider five different diets. And to see if the differences between these five groups are statistically significant when measure a continuous variable, which is the weight loss. Again, the larger the difference between the groups, the less likely this is by random chance. So at the end of the day, we are showing, for example here, that diet 5 is much more effective than the other diets. Continuing with the quantitative methods to test hypotheses, now we are going to talk about correlation, about regression analysis. The most simple case of correlation is the simple regression for prediction. In that case, we will have a continuous variable, like for example income, affecting a dependent variable that usually is also continuous. So the regression analysis help us to study the relationships between a set of variables called the independent variables and another variable which is called the dependent variable. In the simplest of cases, the set of independent variables only contains one variable, and regression is the study of the relationship between two variables, let's say x and y. First of all, I would like that you can clearly distinguish between dependent, independent, and control variables. The independent variable is the one that you think might be the cause of the phenomenon that you are observing. And then you can measure the dependent variable, the one you think might be affected by the independent variable, to find out what is the effect might be. But at the same time, when we are observing a phenomenon, we will probably also have variables that you need to consider constant in order to focus on the effect of the independent variable over the dependent one. Here you can see a table to clearly identify the different types of variables and a simple example of an experiment to understand the concept of independent variable, dependent variable, and control variables. So we will use correlations when we have no grouping variables. If you remember for t-test and ANOVA, we had grouping variables, but in that case, we have at least two continuous variables. In order to see the relation between these two variables, we usually start by plotting our two variables on a scatter plot to help visualize if there is any correlation. In that case, we will assume that we will find no correlation. So this is the starting position now. This is the null hypothesis. And we will be collecting data to try to check and disprove the null hypothesis by finding an statistically significant correlation. The simple linear regression model takes the following form, where y is the dependent variable, x is the independent variable, beta sub 0 is the intercept, beta sub 1 is the coefficient of x, and u is an error term. Here you can see a very simple example about correlation between age and reaction time. Obviously here we have a direct relation. The bigger the age, the bigger the reaction time. As I say, the scatter plot will help us to visualize any relationship between our two continuous variables. So we can find out if there is a relationship, if the relation is linear, what is the direction, if it is positive or negative, what is the strength of the relation, how these points fit with this line. So here you have a very simple example relating the average approval rating for a president and her or his height. So if the correlation coefficient is 1, there will be a perfect correlation. However, in that case, the correlation coefficient is only 0.2. So it means that basically we have a dispersion of points that don't fit with this line. So the main challenges about linear regression and correlation in general is that the relationships between the variables are never going to be perfect. As you know, the real world is much more complex than the mathematical models. So it's difficult to ensure that we are capturing the relationship between x and y and all else variables are being equal. One of the utilities of regression is interpolation. Okay, so if we found a correlation between two variables, then we can interpolate data for values that we didn't have at the beginning. In that case, for example, we didn't have the data of team reaction for the age of 70. Interpolation is where we find a value inside our set of data points, because our set of data points include a value close to 80. But also we can extrapolate data. I mean, extrapolation is where we find a value which is outside our set of data points. In that case, for example, the age of 100. So in our example, we are using age to predict the reaction time. So the reaction time is the dependent variable and age is the independent variable. And if by using statistics we already know the value of m and c, we can use age to estimate the reaction time. Finally, we are going to talk about multiple linear regression. That is the case when we want to analyze the influence of several continuous variables on the dependent variable. Basically, the multiple regression is a generalization of a simple regression. Now we use several variables to study how the dependent variable change based on several independent variables. In that case, the coefficient of x sub I on the dependent variable is the effect of x sub I on y when the other variables are held constant. In addition, we can use both continuous and discrete variables as independent variables. Here you have an example of a dataset that contains information about salaries of faculty members in a small use college, and we can consider 6 variables in this data frame. Basically, how these independent variables are going to affect the salary. So following this data set, an example of a simple linear regression would be this question: does the salary depends on experience? And by observing and making the calculation, we can see that there is a significant correlation between the salary and the years since the degree was earned. It means the experience. But here we are still comparing two variables. However, in a multiple linear, the question would be, it is possible that salaries of academics do not only depend on year of experience, but also on their rank? So here we are comparing the years of experience, the ranks by using the colors, and the salary, and observing the statistical significance by using the statistical models. And finally, here you have some conclusions about that session. The first one is that by using inferential statistics, we can deduce the information about the entire population using only a representative sample. The second important point that you need to understand is that the different statistics methods for hypothesis testing will depend on the type of variables and the number of variables that we want to compare or correlate. To find differences between groups when measuring a continuous variable, we use the t-test or ANOVA, depending on the number of groups that we are going to compare. For 2 groups, we will use the t-test. For more than 2 groups, we will use the ANOVA. And finally, if we want to find relations and the influence between continuous variables, we will use correlation analysis. We can use the simple linear regression if we are looking at the influence of one continuous variable over other continuous variable, or multiple linear regressions when we want to study the influence of different independent variables over a dependent variable. This is all from me now. In future sessions, we will explain how to apply these calculations in Python. I hope to see you soon in our next synchronous session. Goodbye.